Hi everybody, this is Mr. Ruger again. This is the third Edmodo YouTube video of the afternoon, so let's get right into it. I want to talk to you guys about factoring. Now, sometimes we have trinomials or binomials for that matter, where we're just simply going to have to factor. Factoring is the reverse of multiplication. If we think of multiplication, its inverse is division. But if we're talking about polynomials, then we multiply polynomials, but in order to do their inverse, we have to factor. So it's our double distributive property, our multiplication backwards. That's what factoring is. So we have a problem here. 2x squared plus 5x plus 3 equals 0. Once again, we have it set equal to 0, so at the end we're going to have to solve it. It's not just enough to factor it. But start off the process, we're always going to take the two outside numbers and multiply them together. Regardless of whether there's a number out here or it's an understood 1, multiply the two outside numbers together. 2 times a positive 3, that is a positive 6. Now, my two symbols in the inside, or my two signs on the inside, are plus plus. That means I'm multiplying and getting a positive, and I'm adding and getting a positive. That means that both of my factors have to be positive, and it has to equal the number on the inside, which is 5. So what are we going to do? We're going to look at the factors of 6, that add to give me 5. Well, in this case, it's pretty easy because we actually already have them. 2 and 3. 2 plus 3 is 5, so 2 and 3. Okay? Now what we have done is now we have taken these are actually your middle terms. So these are your x terms. So instead of saying 2x squared plus 5x plus 3, we're now going to say 2x squared plus 2x plus 3x plus 3 equals 0. Okay? So instead of saying 5x, we've just now used these two terms to represent the middle term. Okay? Now, there's two ways to do this. There's factoring by grouping, and then there's the area model, which is essentially the factoring by grouping. It's just using a little bit more visual for the visual learner. So we take the two numbers on the outside, and the first two numbers and the second two numbers, we're going to group them together, and then it's all about the greatest common factor. What's the greatest common factor of 2x squared and 2x? It's just going to be 2x. What's left over? If I take 2x squared out of here, I take it out by division. So that 2 is gone, and one of those x's is gone. So all that's left is just x, and I divide this by 2x. Now this is where some kids get confused, and they think, oh, well, if I take out a 2x, there's nothing left. But we take out by division. So 2x divided by 2x, there's going to be left a positive 1. Okay? Same thing here. What do they both have in common? They both have a positive 3. I divide both sides by 3, and I'm left with x plus 1. Now, the big idea is, are these two the same? Is x plus 1 the same as x plus 1? The answer to that is yes, so that makes me happy. You see the smiley face? So my answer is going to be 2x plus 3 and x plus 1. Now that equals 0. Once we get here, we then have to solve it. We solve it because we know that the multiplicative property of 0, of a times b, equals 0. That only happens if a equals 0 or b equals 0. So that means that either 2x plus 3 equals 0 or x plus 1. So either 2x plus 3 equals 0 or x plus 1 equals 0. This one is really simple and easy. We can look at it. We don't really have to do the steps. We know this is going to be a negative 1. And then we look at this guy here and we see that I subtract 3 from both sides. And I'm left with 2x is equal to negative 3. Divide both sides by 2. And my second answer is negative 3 halves. So here's one answer, and here's the second answer. I hope that was helpful for you guys. As always, please check back into Edmodo often. You can look at these videos all you want. They're always going to be here for you. If we can be of any help, make sure you ask questions in class, email your teachers, check Edmodo, come into tutorial, and as always, check our office hours. Have a wonderful day.